Hello everybody and welcome to the homework helper for section 7.10, which is really 7.1 with an extra 0, but it's 7.10. We'll just go with it. Alright, so we'll start with our ready section here. A golf pro practices his swing by driving golf balls off the edge of a cliff into a lake. The height of the ball above the lake, measured in meters as a function of time, measured in seconds and represented by the variable t, from the instant of impact with the golf club is, boom. So here's our equation. Or our statement. The expressions below are equivalent. There's standard form, there's factored form, and there's vertex form. So all of these are the same thing. We just kind of have to think about which of these makes the most sense for us, right? We have some cliff, we have some golf pro, and he's hitting some ball like that into a lake. Okay, so which expression is the most useful for finding how many seconds it takes for the ball to hit the water? So where does the ball hit the water? Let me zoom in a little bit on my little mock diagram here, okay? Where does it hit the water? Splash, right here. So this would be what? This would be our intercept. This would be our x-intercept. So what we would be wondering is where this is, and which version helps us find our x-intercept the best? That would be factored form. Factored form tells us our x-intercept. Okay, which expression is the most useful for finding the maximum height of the ball? Well, the maximum height of the ball is going to be here. Okay, that's the top of the curve. And so what is that? Well, that's going to be our vertex. So which one helps us find that? That's going to be our vertex form. Okay? And so all of these are going to be, we're going to have to think about what the graph would look like, what part of the information we need, et cetera, et cetera. So hopefully that's a good start for you guys to answer 3 and 4 from there. All right, let's go ahead and move on. This one is asking us to find multiple representations of a quadratic. So given a representation, we want to find the other representations. So what it gives us here in number 5 is just the factored form. And so what we do know about factored form is factored form will allow us, whoopsie, it helps if I don't slide my paper. Factored form tells us where our x-intercepts will be. Okay. Remember, whenever we have this factored form, like right here, we have y equals x plus 5, x minus 3. And so these are two numbers being multiplied together, right? This is like, and so if this were to equal 0, the whole thing would be 0. So if x plus 5 equals 0, then this thing would be 0, this binomial will be 0, 0, multiplied by this other binomial will be 0, therefore we'd have our answer. So we know that x equals a negative 5 is one of our answers, because if negative 5 were x, it would cause it to be 0. Same thing with this binomial. If this binomial were 0, the whole statement would be 0. So 0 equals x minus 3, so if I add 3 to both sides, 3 equals x. So those are my two zeros. Those are my two intercepts, my two x-intercepts. So when I look at my graph here, I know that negative 5, 1, 2, 3, 4, negative 5, and 3, 1, 2, 3. Those are 2 points on our graph. Okay, so we've got that much. Boom. But that's not enough for the graph, right? We can figure out what our axis of symmetry is and all of that, but that doesn't necessarily help us because we want to be able to figure out more than that, okay? But let's go ahead and fill in part of this graph. We know that negative 5 gives us a y of 0, because that's this here. This is negative 5, 0. And we also know that 3 gives us a y of 0, so 3, 0. And we're going to have to figure out what's going on in between. Okay, neat. Now what do we do? Well, let's see, we have it in factored form. Let's try standard form, because that means we just have to FOIL it. So if we just FOIL this, x plus 5 times x minus 3, okay, first will be x squared. All right, outer will be minus 3x. Inner will be plus 5x. And then last, 5 times negative 3 will be minus 15. So my standard form will be y equals x squared, combine my two x terms, plus 2x minus 15. Cool. So my standard form is x squared, y equals, don't forget that y equals, plus 2x minus 15. Okay, okay, getting there, getting there. But I do know something, right? This is going to be my intercept. Negative 15 is going to be my y-intercept. And so maybe this won't fit on here, right? This is pretty small. 1, 2, 3, 4, 5, 6, 7, 8, 9. I only get to go 9. So maybe what I'll do, maybe I'll count by 2's, right? I'll have this be 2. So 2, 4, 6, 8, 10, 12, 14, 16. So it's going to cross right there. So 0, negative 15 is one of my points. So 0, negative 15 is another one of my points. All right, I'm getting closer. I'm getting closer. But I am going to want my vertex at some point. And there's actually 2 ways to find our vertex. We could complete the square in vertex form. That's one way. We can complete the square. Complete the square. Or another way we could do it is we could use our x, or our axis of symmetry, and be able to find our vertex that way, axis of symmetry. Okay, so which way do I want to do this? Well, I'm going to do them both. I'm going to complete the square first. So y equals x squared plus 2x, and then I'm going to briefly ignore the minus 15. I'm now going to complete my square. I'm going to take b over 2 squared. So I'm going to add in b over 2 squared, and then I'm going to subtract b over 2 squared here. So that becomes y equals x squared plus 2x. Okay, what is b over 2? Well, my b is 2, so 2 divided by 2 squared, and then minus 15 minus 2 over 2 squared. So that's y equals x squared plus 2x. 2 over 2 is 1 squared, minus 15 minus 1 squared. Well, 1 squared is just 1, so that's just plus 1. So this is y equals x squared plus 2x plus 1 minus 15 minus 1. So this is a perfect square. Y equals x plus 1 squared. And then this is going to be minus 16. So now I know my vertex. Okay, I know my vertex form is y equals x plus 1 squared minus 16. But I can also do it by calculating my axis of symmetry. To do it by calculating my axis of symmetry, I need to first find my axis of symmetry. So I have my zeros, right? I know what my zeros are. I know negative 5 and 3 are my zeros. So if I add those together and divide by 2, I'll get the average. Okay, so negative 5 plus 3 is going to be 2. Oh, I'm sorry, negative 2. It's a negative 5 plus 3. And then I'm going to divide by 2. So I know that negative 1 is my axis of symmetry. X equals negative 1. So when I look at this, I know that x equals negative 1 is my axis of symmetry here. Cool. So now that I know that my vertex will be on that point. So I can take any form and plug negative 1 in. You know, I can do factored form, I can do standard form. I'll do standard form. So I'll say y equals negative 1 squared plus 2 times negative 1 minus 15. This equals 1 minus 2 minus 15. 1 minus 2 is negative 1 minus 15 is negative 16. Whoops, lost it on the bottom there. Negative 16. And sure enough, we already knew that from here. So we know that negative 1, negative 16, 2, 4, 6, 8, 10, 12, 14, 16. There is our vertex. All right. And so now that we have this, we know what our graph looks like. Looks like this. All right. And then finally, nope, that's it. Cool. It says it wants 2 points on either side of the vertex, so we got to go negative 1, negative 16. We have 2 points below. We can just do 2 points above. So we know that negative 2 would bring us up to a negative 15 as well. And we've completed the task. This is repetitive, but it's worth looking at each and every one of these to really fill in all the things that we do know about how these behave. All right, let's move on to the final section. And for this one in the Go, we're going to be factoring quadratics. And so what it wants us to do is it wants us to verify each factorization by multiplying. So what that means is we're going to take the right side and we're going to factor we're going to FOIL those. So I have x plus 16 times x minus 4. And when I FOIL it, I should get x squared plus 12x minus 64. So let's see if that's true. So I will do the first terms, x squared. I will do the outer terms, minus 4x. I will do the inner terms, plus 16x. And I will do the last terms. 16 times negative 4 is going to be a negative 64. Okay. Combine my middle terms, x squared plus 12x minus 64. And is that what I had? It is. I verified it. Okay, so that's what these are asking you to do, is to just double check it, which really just means you're going to be looking through these, and we're going to FOIL this, we're going to FOIL this, we're going to FOIL this. And what I want you guys to really pay attention to on these is that the things that change between these two are their signs. This becomes positive, and otherwise it's the same thing. This becomes negative, otherwise it's the same thing. And just see how that changes our middle terms, right? Let's see how that one positive or negative shift really changes our output, okay? That's going to be really important to start to see those patterns and how they develop. All right, and then finally, it says, factor these if it's possible. Some will not factor. And just scanning it, looks like they're all A equals 1, so that's going to make it a lot easier, because in this case, we just need to make sure that our C value, what multiplies to be C adds to be B. So what two numbers multiply to C but add to B? Well, it's going to be negative 3 and negative 2. So x minus 3, x minus 2. Same here. 63, so it's got to multiply to 63 but add to 16. What multiplies to 63? That's 9 and 7. Do those add to 16? You'd betcha. M plus 9, M plus 7. But be wary, because some will not factor. And make sure you recognize when they don't factor. So for example, look at number 19. Okay, what numbers multiply to 2 but add to 7? I can't think of anything, because 2 and 1 will be 3, but they will not be 7. So that will not get us there. This is one that won't factor. So this would be a problem that we'd have to do a different way, maybe completing the square and getting it into vertex form if we wanted to graph it from this standard form. But that's about it, guys. Good luck on your homework, and I will see you tomorrow.